Okay, we're looking at one of our need-to-knows today, which is the result as follows. That when we differentiate, let's just say tan𝑥 generally, okay, we get the result sec squared of x. And we need to use this result forwards and backwards. So knowing it and recognizing it quickly is very, very convenient. First question, differentiate tan of 3x and show that it's 3 sec squared 3x. So let's use sort of the formal approach to do this then. So I'm going to assign tan y, and I'm going to say that I'm thinking of it being tan u. I'm going to do u equals 3x. So this is a chain rule. I'm just doing it in a formal way because it says show that. So generally, tan differentiates to sec squared. That's the result that we said. And du dx would be 3. The chain rule sort of says that if we're trying to differentiate the thing, which we have called y, that dy dx is equal to dy du multiplied by du dx. In other words, this will be this part and this part together. So it's going to be, what is that going to be? That's going to be 3 sec squared u, and u was, if you go back, u was, or du was 3. Du was 3x. There we go. That's what we were looking for. Okay, so we've demonstrated that result there. And now the next bit is hence. So we're meant to look for a link from before. Hence, find the exact value. So sort of surds, perhaps, something like that, of this one here. Now, what we see is that tan 3x differentiated to 3 sec squared 3x. And this here is 6. So we want to take advantage of knowing that result and using that result backwards. First thing I'm going to do then is I'm going to say, well, if tan of 3x became 3 sec squared 3x, well, how is 6 sec squared 3x related? Well, it must be double them. Okay, so we can sort of scale up results when a constant is involved. We can scale up results on both sides. So I'm going to, well, I mean, we've kind of just done that there by inspection. But if we wanted to do that a little bit more slowly, I suppose another way you could think of this result was that this was equivalent to 2 times 3 sec squared 3x dx. Then the 2 was sort of taken out to the front. Okay, so this is another way that you could think about it if you like. So really what we've got here is we've got 2 tan 3x, and we've got some limits here, haven't we? So we've got pi over 12 and pi over 18. Okay, the 2 in a situation like this, it's generally easier to leave the 2 out of the way and introduce it right at the end. Okay, and then we can just do tan of 3 times pi over 12 minus tan of 3 times pi over 18. Okay. And if we do all of that, this turns into 2 being multiplied by, well, this is like the same as tan 45, so it could just give you 1. Okay, and this is pi over 6, which is 1 over root 3. Okay, so we get this result, and the final answer is going to be 2 minus 2 over root 3. Okay, and you can see the root 3's mean that it's an exact form. So that's our first illustration of the result that tan differentiates to sec squared x and trying to apply that. Here is a slightly different one. I want you to take a moment to pause the video and have a go for yourself with this. And assuming you've done that now, your situation here instead was slightly different as you had a product rule. So the shortcut we've talked about in previous videos is keep differentiate and differentiate keep, which would mean that f dash x, if I keep the x, I get x. Tan differentiates to sec squared x. That's the result that we've been using. So that's the keep differentiate. And now you add on the differentiate keep. If you differentiate x, you get 1. And if you keep tan, you get tan x. Okay, so that would be the derivative with respect to x. And now we've done that, we're supposed to find the value of this thing over here. Well, the 5 can just be taken out to the front. So what do we notice now? Well, hopefully we can see that we have the same expression. So this means then I will have 5 lots of, so we differentiated here, so let's use it backwards now. We're going to get 5 lots of x tan x at those limits of pi over 4 and pi over 6. We're going to put a 5 on the outside again. We're going to sub in the results, okay, just to make it nice and clear. And you can see again, you know, pi over 4, tan pi over 4. Pi over 4 we had on the previous slide as well, for example, which was just 1, wasn't it? And then over here we're going to have pi over 6 tan pi over 6. And if you do all of this, you should get 5. And inside the brackets, I believe the equivalent is pi over 4 minus, there's a couple of ways of writing the next one. I'm going to write it in this form here, pi over 6 root 3. And you get your final answer, which is 5 pi over 4 minus 5 pi. We could rationalize it. If we rationalized it, we would get this result here. Okay, so both of these examples today were sort of illustrating how part A, where we do some work on the derivative and we realize that tan differentiates to sec squared, how that can then be used in a part B with some integration.